Alright, you are welcome again. You are still solving limit under calculus. And then let's take this question for today. Evaluate the limit if it exists. Lim as x approaches 64. Square root of x minus 8 all over cubic root of x minus 4. So this is what we are asked to solve. So if we insert 64 wherever we see x, we are going to have 0 all over 0. So we want to avoid this. What can we do? Now let's go. We have lim as x approaches 64, square root of x minus 8, all over cubic root of x minus 4. Now we want to rewrite this our function. So we can write it in another form. Which format? Now let's see how we can rewrite it. We can write it this way. Lim as x approaches 64. This square root of x can be written as x raised to power 1 all over 2. Then we have minus 8 all over cubic root of x can be written as x raised to power 1 all over 3. Then minus 4. Okay? Hope you are not confused here. Please, if you don't understand clearly, please, I will refer you to our laws of indices. One of our tutorials are laws of indices. Please watch that. I think it will help. Okay? Good. Now let's go. We are having lim as x approaches 64. X raised to power 1 all over 2 minus 8 all over x raised to power 1 all over 3 minus 4. Okay? So, pay attention please. We are having x in a numerator and x in a denominator. And then in a numerator, it is having raised to power 1 all over 2. In a denominator, it is having 1 all over 3. That is raised to power 1 all over 3. So, we are going to take this 1 all over 2 and then 1 all over 3. What is the LCM of the denominator of these two numbers? The denominator of these two numbers is 2 and 3. So what is the LCM of these two numbers? So we are simply going to say 2 times 3. This will give us what? 6. So we are going to replace x with y raised to power 6. This denominator we have just gotten. Sorry, the LCM we have just gotten. So that means anywhere we come across x, we are going to replace it with what? Y raised to power 6. Now, pay attention again. As x approaches 64, y will approach a value. So what value? We are going to say what is the number that when you raise it to power 6, it will give you 64. So that value will be what? 2. 2 raised to power 6 will give you what? 64. So we are going to say as x approaches 64, y will approach 2. Hello. Now let me show you what we want to do. We are going to replace x with what? Y raised to power 6. And then as we are replacing y raised to power, as we are replacing x with y raised to power 6, y will now approach what? 2. Okay, now let me show you. We'll have lim as x approaches 64, x raised to power 1 all over 2 minus 8 all over x raised to power 1 all over 3 minus 4 is equal to lim as y approaches 2. So anywhere we see x, we are going to replace it with y raised to power 6. Now we are going to have y raised to power 6, open bracket 1 all over 2, minus 8 all over y raised to power 6, open bracket 1 all over 3, minus 4. Is that clear? Yes. Now let's open this bracket. So we are going to have 6 times 1 all over 2. So 6 times 1 is 6. Divided by 2 will give us what? 3. Okay. Now in our denominator also, what are we going to have? We'll have 6 times 1 is what? 6. Divided by 3 is what? 2. Now let's go. That means we are going to have lim as y approaches to y raised to power 3 minus 8 all over y raised to power 2 minus 4. Hope you understand how we get this y raised to power 3. So this y raised to power 3, we got it from saying 6 times 1 all over 2. It will give us 6 all over 2. 6 all over 2 is 3. So we are having y raised to power 3. It will have minus 8. And then this y raised to power 2, we got it from saying 6 times 1 all over 3. So 6 times 1 all over 3 will give us 6 all over 3. 6 all over 3 is the same as saying what? 2. So we're having y raised to power 2 minus 4. Okay? So we discovered that we can reduce this 8 to base 2. And then reduce 4 to base 2. So in doing so, what are we going to have? We're going to have lim as y approaches to y raised to power 3 minus 2 raised to power 3. Because when you say 2 raised to power 3 is 8. All over y raised to power 2 minus 2 raised to power 2. That is for 4. Because 2 raised to power 2 is the same as what? 4. Okay? Good. Now, let's see what we are going to do again. We are having lim as y approaches to y raised to power 3 minus 2 raised to power 3. All over y raised to power 2 minus 2 raised to power 2. Now, y raised to power 3 minus 2 raised to power 3 can be written as y minus 2 in bracket y squared plus 2y plus 4 all over this y raised to power 2 minus 2 raised to power 2 is difference of 2 squared. And then y raised to power 3 minus 2 raised to power 3 is difference of 3 squared. Okay? Now let's go. We are going to have in a denominator y minus 2 in bracket y plus 2 in bracket. Okay? So we are having y minus 2 in a numerator and y minus 2 in a denominator. They can cancel out. So we'll be left with lim as y approaches to y squared plus 2y plus 4 all over y plus 2. So from here, let's insert our value. Let's impute our value as y approaches 2. So anywhere we see y, we are going to replace it with 2. In doing so, we are going to have lim as x approaches 2, 2 squared plus 2 of 2 plus 4 all over 2 plus 2. 2 squared is 4. 2 times 2 is 4 plus 4. It will give us 12. Then all over 2 plus 2 is 4. That means we're having 12 divided by 4 is equal to 3. So the evaluation of lim as x approaches 64, square root of x minus 8 all over cubic root of x minus 4 is equal to 3. Okay? Yes. Thank you very much.